This is number 22 from the first semester final exam. This problem has a lot of writing in it, and it may be difficult for you to see it on the video. Therefore, you may want to download the copy of the final exam that I placed on the website so that you can follow along with it at home. Okay, so this is number 22. It says Myra invests $5,000 in a bank. The bank pays 6% interest, compounded 4 times a year. To the nearest tenth of a year, how long must she leave the money in the bank for it to triple? It asks us to use the formula A equals P times the quantity 1 plus R over N to the NT, where A is the amount accrued, P is the amount invested, R is the interest rate, and T is the length of time in years. Okay, I'm going to write this down and put down the things we know. So first of all, it's asking us to use this formula. The A, that stands for the amount of money that's in there, is equal to P. That P, it stands for, the fancy word is principal. That's the amount of money that you start your investment with. Times the quantity 1 plus R, that's the rate. Remember, you always should put your rate as a decimal number, over N. This is the number of times that it gets compounded. And this is all to the NT. Number of times it gets compounded times the length of time that you're investing. Let's going to use this. Let's try to identify these values. Well, first of all, we know that P was the amount invested, and it said that Myra invested $5,000. So this is A is equal to $5,000 times 1 plus, what is the rate? Well, it says up here that the rate is 6%, but do not write it as a 6. We need to write 6% as a decimal. So 6%, that's 6 divided by 100, so that's 0.06. So this is 0.06 when you write it as a decimal, divided by n, the number of times that it was compounded. Based on the problem, how many times did it say it was compounded? Well, it says it was compounded 4 times a year. So the value of n is 4 here. This is all raised to the n, which we said is a 4, and then the t, which we do not know yet, but we're going to solve for it, okay? Let's simplify what we have here a little bit. We're just going to simplify this. So this is A, that's the amount that we have, is equal to 5,000. I'm going to simplify this part of the inside by using my calculator. That's 1 plus 0.06 divided by 4. What does that give us? Well, that gives us second entry, 1 plus 0.06 divided by 4, that's 1.015. So this is 1.015. This is just what we get when you type this part in the calculator, and then we're going to raise this to the 4t. Good. Well, we're ready to try to solve for t, but what is the amount of money we want to have before we can solve for t? Well, it says that we're trying to find the time when this value has tripled, right? It says that the amount that we put in there has tripled. Well, if we triple the amount of money we put in there, how much do we have? That's right, that's 5,000 times 3. 5,000 times 3 is equal to 15,000. So we have to find the time that it takes for us to get to 15,000. Why? Because it says that the amount tripled, and the amount we put in there was 5,000. 5,000 times 3 is 15,000. So we have 15,000 is equal to 5,000 times 1.015 to the 4t, right? And basically we're trying to solve for t. Now, anytime that you're solving for a variable that is in the exponent, you should be thinking, this is a good time to use a logarithm, right? If you're trying to solve a variable that's in the exponent, think about using a logarithm. Well, before we can use the logarithm, we need to isolate this exponential part, right? As we have done many times on many other equations, you isolate that part you want to work on first, okay? So to isolate this, we're going to divide both sides by 5,000. Good. Well, 15,000 divided by 5,000 is 3, is equal to, those 5,000s cancel out, is equal to 1.015, right, to the raised to the 4t. So this is a pretty nice little equation we have now. And now we're actually ready to take the log of both sides. So I'm going to take the logarithm of both sides. So I take the log of 3. This is the log of the left side. That has to be equal to the log of the right side. So this is the log of 1.015 to the 4t, right? See how I took the logarithm of both sides of the equation? Now we get to use those nice laws of logarithms to bring down the exponent. Remember that exponent is on the outside here, up is up in the exponent, up in that part of it. I'm going to bring it to the outside as a coefficient. So this is the log of 3 is equal to 4t times the log of 1.015. So far, so good. What are we solving for here? Yeah, we're solving for the time. So we need to isolate that time. What do you want to get rid of so that the t would be by itself? Well, I need to get rid of that 4, and I have to get rid of the log of 1.015. Here's a nice way to do it. How about if we just divide this entire side by what we want to get rid of? So that 4 will cancel, and I'll also divide it by the log of 1.015, right? I'm dividing the right side by 4 times the log of 1.015. Whatever I do to the right side, I have to do to the left side. So this is 4 times the log of 1.015. These guys cancel out. This t is what remains. So t is equal to the log of 3 divided by 4 times the log of 1.015. If you don't like having the variable on the right, you can always just put the equal sign and rewrite it. So this is the log of 3. This is not necessary, but it's just something that people like to look at sometimes with the have it written so it's t equals something rather than something equals t. So 4 times the log of 1.015, right? So here is our expression for what is t. The problem wants us to actually give the time that it's invested in years, right? So, it wants us to actually give us to the nearest tenth of a year. So let's do this to the nearest tenth of a year. We're going to type this in the calculator and then find that value to the nearest tenth of a year. So t is equal to, I'm typing it in the calculator right now, that's the log of 3, and then that is divided by 4 times the log of 1.015. I'm using my parentheses here. I press enter. I end up with 18.447. So this is t is approximately equal to 18.447. It said to the nearest tenth, though, didn't it? Yeah, it said to the nearest tenth of a year. And so rounding this to the nearest tenth, we get t is approximately equal to 18.4 years. Good. I'll just show you how I got that on the calculator here. I typed in the log of 3. Here it is, the log of 3 divided by, I used a parentheses to put my entire numerator in parentheses, 4 times the log of, this is 1.015. I pressed enter. It gave me this. I rounded that to the nearest tenth. We got this. Here's our answer to the nearest tenth. 18.4 years until our money will triple.